I'm working on a model 1897, Winchester model 1897. It is a riot gun that started life as a trench gun according to the provenance of this, the serial number and what have you. It World War I manufacturer, and at some point it was converted to a trench gun, from a trench gun to a riot gun. The handguard's gone. It only has one notch here, but it also at some point became apparently the Phoenix Police Department. What we're dealing with here, I've got an issue with it in that it is a little bit finicky on ammunition. It processes the snap caps fine. It processes some federal ammunition just fine. We fired a couple of things through it, but when I came to Remington double-aught buck and Fiauci double-aught buck, it has problems with it in that it won't chamber it completely, or if it does chamber it completely, you can't get it open. So let me show you what I'm talking about here. We've got this shotgun is designed so that the bolt from here, the bolt closes and the carrier, which is down here, pivots up and engages the lug on the bolt. As you can see on the bolt here, this is the bolt. There's a lug that protrudes down below the bolt, and this lug is engaged by the carrier. When you close completely, this carrier pivots up. So when on firing, when the cartridge fires, it applies its force to the bolt. That force is transferred here on this surface here to the carrier, and then from the carrier is transferred back to the receiver where this bolt pivots. There's a fairly large bearing surface back here. So it transfers the force, keeps the bolt locked. One thing about this shotgun is that it is exposed hammer. But one thing about it is that when you push the release, you've got to push forward and back. You can't just open this bolt by pushing the release or firing it and pushing back. You've got to push forward and then back. Now on firing, the recoil usually does that anyway. The recoil of the firearm when it fires, actually your hand is up here and it acts to unlock that little mechanism. So what we've got, snap caps. Put a snap cap into it. Everything's fine. I can actually push with my thumb, see a little movement here to where there's a little bit of play right here between that bolt and that carrier. So when you want to eject, out she comes. Same thing with these federal cases. Here's a fired, this is fired federal case. And this thing's been shut so many times. That case, I've used it quite a bit. But again, the bolt has some play in it. And the bolt is very small gap right here when this carrier flips up between the carrier and the bolt. And there's a little gap where it as should be here between the bolt lug and the carrier. Again, no problem. Now if I take the Remington, now this is a live round. I've got some Remingtons I've been using for this exercise that originally jammed this gun, but I've slammed them shut so many times the rim thickness has apparently compressed. If you look at, I don't know if you can see it, if you look at these two rims, you can see the Remington, and this is not a fault of the Remington, They're probably both manufactured to SAMI specs, but the Remington brass rim is a little thicker than the Federal. So it's probably to SAMI. Remington's not going to make something other than that. But if I put the Remington in there, and I'm going to use a unfired round because this is fairly new round, and I'm going to watch my sealing and keep my finger off the trigger. Now, what we have, I've chambered this in a reasonable force, but there's a gap here. There's a little gap, more so here. And now, if I try to open this, I might be able to push it forward and then back, see? Now, if you're on the range trying to do that, and sometimes we literally could not do it. Okay, so I'm going to do the Fialki, close it. Okay, I can't get it open. The only way to get it open is to stick something in the gap and pry down on it. Yeah, see, I had a lot of friction there. So once you pry the carrier down, you're good to get her out. You know, there it goes. So we're going to work on the headspace here. It's got probably minimal headspace. I'm going to rent some headspace gauges and a tool, a reamer, that will cut that chamber if necessary. But that's the condition that it's in right now. Continuing our little project here on this model 1897, I have received from 4D Rentals, 4D Reamer Rentals, I have received the headspace gauges for the 12 gauge shotgun, and also I rented a reamer just assuming that I was going to have to do this. So we're working on this shotgun, and the problem as we've gone on is that some of the ammunition jams in it, it will not chamber. I've taken the bolt and I've removed the extractor off the bolt. Both of them, there's extractors on either side. I've removed a rod, it's a firing pin locking bar in the bottom, so that this bolt will slide right in and out of the shotgun. And then the carrier, it had the action bar lock bar in here, and I removed that. There was in this groove right here. I removed that, and there was a spring here I removed, so this carrier now will just drop in place. You don't have to do that to use the headspace gauges, but here's these headspace gauges. They are basically like a shotgun cartridge, but as you can see, there's a go gauge and a no go gauge. Has printed on it go and no go. Turn it over to where you can see it. Some of y'all may be familiar with this. So these are basically steel machine blocks, and you can visually with the eye, you can see the difference in the rim thickness on the two. So the go gauge has a thinner rim, and the theory being that the go gauge, you should be able to close the bolt chamber this gauge. The no go gauge, you shouldn't quite be able to chamber it. You could chamber it probably, especially on a rimmed cartridge. Shotgun's not that much pressure in it, but there is another gauge called a field gauge, and the field gauge should definitely never chamber. So what we're going to do is we're going to see what this shotgun does now with these two gauges, because my suspicion has been that the headspace is too tight, and therefore some ammunition, which is still within ANSI specs, will not chamber, will not lock up, or if it does, it jams the action so tight you can't extract it, you can't open the action. So this bolt, I've got it now, just slides right in. The carrier, we'll just put this carrier in. And then we'll just drop the cross pin for the carrier, cross pin in. So now we've got an action that basically has no action bar. It should close. And you can see the locking surfaces on this are right here. This surface, as we've talked before. So if you drop the carrier, the bolt will come back. But with the bolt fully forward, there's a little bit of a gap here. There's the play. See if you can see. I think you can see that. Now, the question is, what will it do with the go gauge? So here's the go gauge. We're going to open the bolt. We're going to set this gauge in here that I don't want to drop, and close the bolt. Okay, so I'm thumb pressure pushing the bolt up, and now, guess what? No bueno. The bolt will not close because the go gauge is keeping the bolt from going far enough forward for this surface to interface and actually close up. So we now know that definitely the headspace in this shotgun is not enough. It's too tight. Whoever replaced this barrel at some point, some armory, who knows where, somebody replaced this barrel, and they must have set the headspace using probably a cartridge. Maybe they didn't have an actual go, no-go gauge. I've found in studying this shotgun, I've found that a lot of even gunsmiths do not have full sets of go, no-go gauges because it's so expensive. So if they were like me, they probably tried to improvise. So now that's the go gauge. The bolt will not close. Now let's be careful here because I do not want to drop this. I don't want to buy this. Here's the no-go gauge. So we're going to drive it up into the chamber, and it's even worse. It doesn't even come close. I'm thinking it's about 30 thousandths is measurements I've already taken. There's about 30 thousandths of an inch that we're going to have to take off. So it doesn't seem like much, but 30 thou is substantial when you're talking about these clearances. And actually for the no-go gauge to almost chamber, it's going to be probably more like 50 thou, the 40 thou or 50 thou. So what we're going to do is the 1897 is one of the few shotguns. Take this out again. Bolt out. One of the few shotguns where the bolt enters are actually protrude from the back. The early model, John Browning designed it. This was one of the early pump shotguns. So we've got the reamer here, also from 4D Reynolds. And it's got cutting surfaces, the flukes here. The ANSI drawing for the chamber, you can pull it up, the ANSI chamber drawings. Let's not get into that. So this is a 55-degree angle on this cutting shoulder right here. And it's got a guide, it's going to go into the chamber. This is going to wedge up into the forcing cone, the front of the chamber, the forcing cone, and make it straight. So we're going to push that up into the chamber. And like I was saying, the model 1897, most shotguns you can't enter from the back. But this one here, you actually can enter from the back. Do not drop it. I'm going to be able to push this up into the chamber. The receiver is all clear, so it'll have spring pressure. And we're going to drive this in, and we're going to turn it with a square drive, and be able to cut that shoulder to where we can get to that go gauge to work, and almost to the point where the no-go gauge will work. So fortunately, I don't have to pull the barrel off of this. This is a solid receiver, and whoever put the barrel on didn't set it up right. It was a I believe Phoenix Police Department Armory, or who knows who put the barrel. This thing's so old, but it was a World War I shotgun originally, and sometime it was changed from a trench gun to a riot gun, and that would have involved changing the barrel for the standard single notch barrel rather than the trench configuration triple notch. So next we will go after actually cutting the shoulder off of the chamber. So we've got the shotgun now mounted. The reamer is inserted. We've taken some dimensions. And what I've also got is a large, long 3/8 inch square drive extension in here. So we've taken some dimensions from the muzzle to this, so we will know roughly we want to move maybe 15 thou in. So we're going to try to lube this thing up, and I'll try to lube this up real good. Probably need to do better. And I'm going to dump some in there. There we go. I'm going to drive this in a little bit. And they tell me that, of course, you only should drive clockwise, so feels like it's cutting. Do not go backwards. It feels like it's cutting. So we're going to go on like this and then take our new dimensions. I see a little steel coming off. And we'll cut a little bit of this, and we'll take our dimensions and see how we're doing. So we've got about 12 thousandths in already. So we just made another cut. So we've made a number of cuts here. We've gone in there with the reamer, I don't know, 7 or 8, 10 times, and a little bit at a time, and the angle was not right because it started cutting on the outer edge, I believe, before it even reached the inner. So here's now the go gauge, and if we put the go gauge in, and if you remember, this bolt wasn't closing at all, so we slide the bolt forward, and then we close it. It just, bingo. She goes down. As a matter of fact, I've got a 2 thou feeler gauge here I can put in there, and as you can see, it slips right in and out. Well, it slips out as thin as it is. So that tells us we have clearance between the carrier and the bolt. So we're going to call it quits here. The no-go gauge will not close yet, which is the way we want to leave it. By nature, it is the no-go gauge. And so I'll just show real quick where the no-go gauge goes. This is the no-go. And we're going to put that in. We're going to slide the bolt. And as you can see, it actually makes a little bit of progress, barely overlapping. And my Remington Model 31, it does not close either. So no-go, okay. We're going to call it quits here and reassemble this and see how she goes. So we finished doing the reaming, and we've reassembled the whole gun. And now what we've been doing, we've been exercising it. I want to be careful with this, but here's the go gauge. And the go gauge, it will close. I'm trying not to hurt it, but there we go. We've got a good lockup here, and actually the earlier I could get the shim in there. Now with the extractor offering opposite force, it's a little hard to demonstrate that. So don't mess this up. And then with the troublesome cartridges that we had seen earlier, the Remingtons, which were the trouble ones, no problem. The carrier now comes all the way up. It's no longer got a gap here, to any gap to speak of. And she opens, she closes. No, very little friction. She reaches the point where the carrier flips right up. So we ended up taking about 25 or 30 thousandths, was it? About
20 thou, I think.
20 thou. We took about 20 thou off the chamber, but we also found that the chamber throat there, the seating surface for the headspace where the rim is, was actually kind of at the wrong angle, so it's hard to determine exactly how much. So we're going to take this out of the range now, see if we can make some noise.